Okay, this is a solution to that sample problem that Wiley Plus really wanted to throw into section 4.1. What we're going to do is solve this equation by finding a equation for the exponential function and then using it. Now, the information they gave us was that the population in 2009 was 11,000, so I just wrote that down. The population in 2016 was 25,000, so I just wrote that down. And I will remember that what I'm really trying to do is find an equation for the exponential function, so I need to find A and I need to find B. So all I'm going to do at the moment is call this equation 1. I'm going to call this equation 2. And I remember that this says I'm plugging in 9 for t, and I'm getting 11,000. So what I'm getting here actually, right, is I'm getting, this is going to be A times B to the 9th. So I'm plugging in 9 for t, and I'm getting 11,000. Good. Now here, this says when I plug in 16 for t, I'm getting 25,000. So I'm going to plug in 16 for t, and I get something that looks like that. Yay. Now what I'm going to do is divide equation 2 by equation 1. So 25,000 divided by 11,000 is just 25 over 11. Very glad all those zeros went away. And when I take a times b to the 16th divided by a times b to the 9th, I just get b to the 7th. And so what we want to do is just solve for b in such a way that I still have room left over somewhere. I'm going to get 25 elevenths to the 1/7. In practice, I like to leave it there. But what we can do is just put in the numbers for now. But here's the problem. I have 1.124. Now, I've got like, decimals gave me like 12 decimal places. How many should I use with exponential functions? All of them. Exponential functions grow so fast that any round off you do immediately blows everything out of proportion, and you get something that just sucks. So that's B. Yay. I now want A. To find A, I'm going to go back to equation 1 and plug in B. I'm going to get 11,000 equals the A I want times this mess, 1.12. I'm just going to put yada, 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 because I am going to put this into my calculator, to the 9th, like this. So A equals, here, let's write this so it doesn't look like SOA. So A equals that big mess. Now I get 11,000 over our big mess to the 9th. And again, putting all the decimal places in there like this. And I'm going to get that A, let's see, what do I have here, is 3828. 3828. Now put as many decimal places as I can fit on this page. I'm going to put 0244, etc., although I include them in my entire calculation. Now, once I have A and I have B, we do have the equation. So we finally get that P, the equation, equals the number for A, which is, 3828.0244, yada, yada, yada. And I include all those decimal places when I put it in my calculator, times 1.124437, yada, yada, yada. And I put all those places into my calculator. So we have an equation for the exponential function. We haven't answered the question. The question was, what's the population going to be in 2030? So what we want to do to finish the equation and finish the problem is just find P of 30. When I take P of 30 and plug it into my formula for P on Desmos, I got this huge number. I think I got 129,132, I think. 132.2 2, 3, 1, 1. I can say 1. Here we go. 1, 4, 0, 5. And that would be my estimate for the population in 2030. If in 2009 it was 11,000, in 2016 it was 25,000, and it grew exponentially so I could actually find the equation. That's the whole thing.